And hello. Today we'll be continuing on with sets, and in particular we'll be looking at Venn diagrams and how do we use them. So I have two circles here, and you can see I have these little dots in them, and I've named the dots. So this dot is 2, this dot is 10, 6, 4, 8, and these are just names for the little dots in the circle. So then I called this whole circle circle A, and then this circle here, this circle is 1, 2, 3. I have the dots 1, 2, 3, 4, 5, and circle B. Now, what's the point of drawing these circles? Well, they correspond to sets. So, set A, everything inside the circle, has elements. Remember the words elements now, so those are the parts of the set. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Then I have another set over here, set B, which has the elements 1, 2, 3, 4, 5. So these circles just correspond to the sets A, 2, 4, 6, 8, 10, and this circle B has all the elements of set B, which is 1, 2, 3, 4, 5. And I've just placed them randomly. There's no specific way to place the numbers. You can place them wherever you like, as long as they're in the circle. Now, what happens if we wanted to combine the two circles? Like this. So we have one circle, and then we have another circle over here, and we can see they overlap in this little area in the center. So this area is very important, and I'll talk about that in a second. But first we gotta label these circles. So I'm gonna say this circle is circle A. And then let's say this circle here is circle B. Now we call this a Venn diagram. So this is when you have two circles coming together like this. So this isn't a Venn diagram if I just have one circle by itself. If I have two circles coming together, a Venn diagram. Now I have circle A over here, and then I have circle B. And you notice there's a bit where they overlap. Now, what I'm going to do with this little overlapping bit is there anything in A that's also in B? So let me think. Okay, I have 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. Well, 2 and 4, they're both in the same sets. So I'm going to put them in the center here. 2 and 4. Why did I do that? Because it's in circle A. Look, it's inside this circle A. And then it's also inside circle B. Yeah? So the center bit is what we do first when we're filling out these diagrams. Then I'm going to start filling out the rest of circle B. So 1 is in circle B, 5 is in circle B, there's also 3 is in circle B. So do I have all of them now? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 are all in this circle. Now I'm going to look at circle A. So I've already gotten 2 and 4. You see 2 and 4 is also in circle A. So I've already done 2, I've already done 4. I have to do 6, 8, 10. So I have 10, 8, and 6. Again, doesn't matter where I place these dots, or as the proper word in mathematics we use as elements. I can place them wherever I want. I can place the 10 over here, or the 10 there, or 10 over here. It just has to be within this circle. So this is the full Venn diagram of sets A and B combined. So this is set if I drew a Venn diagram with A and B. So this is the set A of 2, 4, 6, 8, 10. And then this is the set B of 1, 2, 3, 4, 5. So again, you always start off doing your middle bit first. What do they have in common? What do they both have? Now there's a special name for this. We call it the intersection. So you might have heard that word before. Let's say where two roads meet when you're driving along in your car. That's what we call an intersection. So the two roads meet at somewhere. You'll also be seeing it a lot in DCG or tech graph if you're doing that. And you'll also be seeing it later on in geometry and coordinate geometry. But intersection just means where two things meet, or where two things are the same. So in this case, what does A have and B also has it, and that's the intersection. Now, what happens if we were given the Venn diagram and we're told, okay, find set X and find set Y? So I'll look at set X first. So what's inside the X circle? Well, I have A, I have D, and then I have everything over here. So I have E, B, and G. So I have A, D, E, B, and G. Then I'm going to look at Y. So I always look, Y has the intersection as well. So it's going to be A and D, and then it also has C and F. So that's how you would write the set if you were given the Venn diagram, working backwards. So, as I always do, I'm going to give you some recap questions to look at. Draw a Venn diagram for sets A and B, and then what is in the intersection of A and B. Okay, so you should get out your sheet of paper and you should have drawn this, but I'll just go over it. So you draw your two circles first, one circle and then another circle overlapping. Always do your intersection first. So what do these two things have in common? Well, they have -5 and 5. They are not the same. This is a bit of a trick question. -5 is not the same as 5. -4 is not the same as 4. -3 is not the same as 3. Very, very careful. So what do they have in common? Well, they have nothing. Nothing is going to be in the middle here. This is going to be my set A. So I'm going to have -5, -4, -3 over here. Then in this circle, I'm going to do 5, 4, and 3. And that would be your Venn diagram filled out. Now I should have labeled over here, this would be A and this would be B. Oh, I did. A and then this would be B. So in this case, there's nothing that they have in common. This can happen as well sometimes. So these two sets, they have nothing in common. Therefore, this intersection will be blank. Okay. What is in the intersection of A and B? 1, 2, 3, 4, 1, 5, 2, 4, 3. Well, the set 1, 2, 3, 4, since it's in A and B. Because look, 1, 2, 3, 4, 1, 2, 3, and 4. 5 is not in A, but they do have 1, 2, 3, and 4 in common. So if I were to draw it out like this with the two Venn diagrams, or the two sets in a Venn diagram, the intersection, the bit where they overlap, would be 1, 2, 3, 4, or we call it the intersection.